Hello students, today we are going to learn pre-algebra, that is whatever is required to learn before we learn full-fledged algebra. So let us quickly revise the axioms of algebra. You heard it right. Just like geometry, algebra too has its own sets of axioms. So axiom 1 is if A and B belong to the set of real numbers, it is denoted by this sign. This particular sign denotes belongs to the set of real numbers R. Then A plus B belongs to R. That is, when two numbers belong to the set of real numbers, their sum belongs to the set of real numbers as well. Okay, now let us move on to the second axiom of algebra. If A and B belong to the set of real numbers, then A plus B is equal to B plus A. So this is the second axiom of algebra. Axiom, for those who don't know, are a set of assumptions so that we can actually prove something substantial. So we assume that these particular points are true, and then on the basis of this we prove the further advanced proofs. Okay, so the third axiom is if A, B, C belong to the set of real numbers, then A plus B plus C, so A plus B plus C is equal to A plus B plus C. So this is another assumption. This is the third axiom. And the last axiom, the second last axiom is there exists a zero in every set of real numbers where or such that for every A, for every is denoted by an inverted A, for every A or every entity which belongs to the set of real numbers, 0 plus A is equal to A plus 0 equals A. So we assume that there is a number such as 0, which when added to any number gives the number itself. This is the third and one of the most important assumptions in algebra. And the last axiom is for every A which belongs to a set of real numbers, there exists A dash such that A plus A dash equals A dash plus A equals 0. So this is basically the fourth and the last assumption, where A dash is the additive inverse. It is known as the additive inverse, which when added to its when a number is added to its additive inverse, like when A is added to its additive inverse, it gives 0. To understand this property better, let me give you a more realistic example. When you add 2 plus minus 2, it gives you 0. So minus 2 is the additive identity of 2. So this is the fourth axiom of algebra. Alright. So moving on to the first theorem of algebra, the very first theorem of algebra. So the first theorem is called green. The left cancellation law. It is called the left cancellation law for addition. Left cancellation law for addition. So if, let us say, if A, B, C belong to the set of real numbers such that, so we assume that such that A plus B equals A plus C, then B equals C. This is the theorem of left cancellation. Now let us see the proof. Every theorem has a proof, and axioms don't have proofs because they are mere assumptions. The assumptions we base our proofs on. Okay, so as A belongs to the set of real numbers, A is a real number, by the fourth axiom, which states that for every A there exists, okay, for every is an inverted A, there exists A dash, or an additive inverse, such that A plus A dash equals A dash plus A equals 0. So this is it. Now in this, let us call this equation 1. So adding now to this equation we have been given, we add A dash on both sides, A dash on both sides, because we know that we have been given this equation, okay, A plus B equals A plus C. So which means that A plus C is equal to A plus B equals A plus C. So when we add or subtract any entity from this and this, the result is going to be equal. Okay, for example, let us consider we have 1 kilogram sugar, and then we have 1 kilogram sugar on this side. So 1 kg is equal to 1 kg, right? If we subtract half kg from this side and half kg from this side, that leaves us with half on both sides, right? That leaves us with half on both sides. Okay, so this becomes half and this becomes half. Similarly, when we add or subtract anything from this and this at the same time, it leaves us with the same quantities, so there's no change. Now we add A dash on both sides. Alright, so adding A dash plus A plus B equals A dash plus A plus C. Alright, and by axiom 2, which states, alright, axiom 2 states that A plus B plus C equals A plus B plus C. So do we see A, B, C here? We see A dash B, A, B, C, A, B, C, don't we? So moving on, by this axiom, by the second axiom, we have A dash plus A into bracket B equals plus C. We know that A plus A dash equals A dash plus A equals 0. So substituting this particular value in this, we get 0 plus B equals 0 plus C. And by the another axiom of algebra, which states 0 plus any number equals the number itself, similarly 0 plus C equals C. So in the previous equation we saw that 0 plus B equals 0 plus C. Therefore B equals C. Hence proved. So this is the left cancellation law. Okay, left cancellation law. Thanks for watching. Please do like our channel. Thanks for watching.